Okay, let's discuss about the standard deviation with the same probability. What is the standard deviation? Standard deviation means that the uncertainty of the expected rate of return. Because that expected rate of return is only the predictions, expectations, it's not a certain amount in the future. That would be kind of variation or some fluctuations. We cannot guarantee certain percentage of rate of return in the future based that made by the past information. Okay, for example, these questions has 3 years, past years, like 10% and minus 15% and 35%. So the expected rate of return, we can just use average because that the realized return in the past information doesn't have any probability, so you can use just the average function. So 10% is expected rate of return of this investment. Then we want to know the uncertainty of the expected rate of return is 10%. So we use the standard deviation that population. If we assume that this 10% minus 15% and 35% is the full information, full data, then we use the standard deviation that population, which is P, right? But if we collect some sample information from a huge amount of data, then we use the sample standard deviation .s. But in this case, let's assume that that information is just the full information. So the standard deviation .p, then drag the past information, then 20.4%. What does that mean? That is uncertainty of this 10%, the riskiness of this 10%. 20.4% upside from this 10%, or downside 20.4% from this 10% expected rate of return. So this expected rate of return has the uncertainty of fluctuations, the 40.8% in the middle 10%. Okay, then what if each case has the different the probability? For example, an investment has a 30% chance of producing a 25% return in a strong economic growth. So we have a probability 0.3 and return 25%. Then in the moderate case, we have 50% chance of producing 10% return in moderate growth, and 25% chance of producing 20%, sorry, and with minus 15% in the economic recession. Then we want to know the standard deviation. In this case, we cannot use just the standard deviation, standard deviation population of this, because it has different probability. We cannot use, because that function standard deviation .p or .s function in Excel assume that each return has the same probability. That means expected rate of return is just average, but that case is not that case. So we should calculate that process with probability. Then we already covered this simple process to get the expected rate of return if each return has different probability. So we just sum up this result, the weighted average rate of return. You can use sum product, just the sum product. When you practice in class, just one column is matched with this column. So the same result, we can use either way. The next step is to know the deviation from the expected rate of return. How do you calculate? Each return minus expected rate of return. That is the distance from the expected rate of return we calculated here. So how do you get it? 25% minus 9%. That is the deviation distance of each rate of return. So in the same way, each cases has this deviation, but those are not the standard deviation. Standard deviation can be used in common, but that deviation is just the deviation in each cases, each return. Then next process is we multiply the deviation itself to the power of 2. Why? Because by doing so, we can get rid of negative sign. Negative sign. Because distance doesn't have a negative. But this also is not the right dimension. This is percentage. What we want to calculate is percentage. But once we calculate the variance, then we will square root this number at the end of the day. But that is the intermediate process to come up with this variance and standard deviation. And then we also apply the probability on each deviation to the power of 2. Why? Because deviation has its own probability as well, like just as the return has its own probability. So how do you calculate it? Okay, this we apply in each deviation to the power of 2 in each probability, and the same way we apply the same way in each cases. Then we sum up this variation like this. So 192.25% is variation. We also can calculate some product of this and deviation, probability and deviation. We match these two columns. The weighted average deviation is the variance. But that variance cannot be used to measure the deviation from this expected rate of return. Then, as I mentioned earlier, we square root of this variance, and then we come back to the percentage standard deviation. So this 13.87% standard deviation explains how that has the upside, the deviation from this expected rate of return, and downside by this 13.87% standard deviation. Okay.